Past tutorials covered most details of floor-on-ground thermal bridge simulation. Here we'll add another feature, a slightly ventilated layer below the floor. We'll start with a pre-configured thermal bridge. Please see the previous tutorials for more information. We'll now set all the required options in Elements tab. First, make sure the A button is active. Set the first element properties option to bridge areas and SI computation mode to wall floor ISO 10211 option B. Now, we just need to create a closed path around the slightly ventilated layer. Its type must be set to ISO 6946 slightly ventilated air layer. Flow direction must be properly set. The same for air layer's thickness. Also, openings area av must be properly set. Now we just need to assign the external boundary condition to the air layer's surface. Mold Simulator will automatically apply a special boundary condition to it. We're ready to simulate As you can see, 2 additional simulations have been performed. One considering the air layer as fully ventilated, the other one as unventilated. The final results are interpolated between those 2 simulations, depending on how much the air layer is ventilated. Now we'll play a bit with the ventilation parameter. First, we'll set it to the minimum. Floor's U value is identical to the one resulting from the unventilated case. Let's see what happens if we set ventilation value to its maximum. Floor's U value is identical to the one resulting from the fully ventilated case. Now let's simulate again with an intermediate value of a V. Please note that the boundary condition inside the air layer has been replaced. On flow simulation, the temperature is the same of the external boundary condition, but the resistance depends on air layer's parameters and the floor-only simulations. The same for mold and surface condensation simulations, but this time also the temperature value of the air layer's boundary condition depends on air layer's parameters and the floor-only simulations